Welcome to Aryabhat Center for Theoretical Physics. This is the fourth lecture on this lecture series Electricity and Magnetism, and in this lecture I am going to explain differential form of the Gauss theorem. And what is Gauss theorem? Gauss theorem is simply relation between Gauss relation between volume, charge, density and change in the electric field intensity E. So this is the relation between volume, charge, density and change in the electric field intensity in the volume. Now we have wrote in the last lecture integral form of the Gauss theorem. It says that change in the area ds electric field intensity, change in the electric field intensity in ds area in a closed area is equal to the q total charge inside that area divided by epsilon naught. So this is the integral form of the what you call Gauss theorem. This is the integral form. So this is the integral form of the Gauss theorem. Integration E dot ds in the closed area S equal to Q in. It means total charge inside this closed loop divided by epsilon naught. This is the integral form of the Gauss theorem. Now how to write differential form. So how to write in the differential form? Suppose there is a closed surface S. As its volume is V, and in this volume there is a charge Q. So in this closed surface there is a volume V, and in this closed surface there is a charge Q. So total volume charge density Q in will be Q total Q V. This is the volume charge density in this closed surface S. It has volume V, and in this V total charge Q. So total charge density in this volume is QV. This is the average charge density, and V. This is the V. This is the charge density and this V. So Q in is average charge density multiplied by the volume V. This V is element volume. So this is the Q in. Now we will substitute this one into this one, and we will get E dot ds equal to Q in V divided by epsilon naught. So this is, we have substituted equation 2 into equation 1. Now we can write 1 by V E dot ds is equal to Qi divided by epsilon naught. This is, we have rearranged this term and wrote integral E dot ds divided by V Qi, or total charge, divided by epsilon naught. Now we can notice if V tends to 0, then what will happen? This whole term will be reduced to a point charge. So by limiting V tends to 0, this whole term can be reduced to a point charge, and this reduction of limitation of V tends to 0 is called divergence of E. It means divergence of E is limit V tends to 0 E dot ds. This is the divergence of E, or delta dot E is limit V tends to 0 E dot ds. Now this Qi is nothing but a charge density. It means we can write divergence of E equal to rho divided by epsilon naught. This is the differential form of Gauss theorem. This is the integral form of Gauss theorem. This is the differential form of Gauss theorem. This rho is the charge density. This is the charge density, and Q in is the charge density multiplied by this volume element V. So Qi is average. This is the average. So rho divided by epsilon naught. And remember, this is the scalar quantity. Scalar quantity. Now this delta function is simply del by del x I, del y del y j, del y del z k. This delta function, and also we can write E as ex I plus ey j plus ez k. So we can write this as ex del y del x plus del y del y ey plus del y del z ez equal to rho divided by epsilon naught, or del x ex plus del y ey plus del z ez equal to epsilon rho divided by epsilon naught. Now you can see that this delta function is vector, and this field intensity E is also a vector quantity, and divergence of this delta dot E, dot product of these two is become what you call scalar quantity. So del x ex del y ey del z ez is equal to rho divided by epsilon naught. So this is, we have wrote this one in the component form, in the x, y and z component. So delta dot E, divergence of E is equal to charge density divided by epsilon naught, and sometimes divergence E either is 0 or divergence E either is negative. When it is the 0, it means it is source. It means for the positive charge. So in case of the positive charge, divergence of electric field intensity always greater than 0. This is called source. And in case of the negative divergence of electric field intensity E negative, it means in case of the negative charge, so it is sink. So when electric divergence of E is greater than 0, which is in the case of positive charge, we call it source, and in case of the negative charge where electric field intensity divergence of electric field intensity is smaller than 0, in case of the negative charge we call it sink. So if this is the source, this is the sink, so they originate from here to here. It means electric field intensity originate from the positive charge and sink into the electric field intensity sink into the negative charge. So this is the divergence of E is equal to rho divided by epsilon naught. This is the differential form of the Gauss theorem, and this one is the integral form of the Gauss theorem. So we can write here divergence of E equal to rho divided by epsilon naught, charge density divided by epsilon naught. This is the differential form. And this is the integral form. So this is the today's lecture, differential form of the Gauss theorem.